I hate it. I hate it when I go to a workshop where it is supposed that somebody has to teach me how to do things, and I don't get those
I
things.
hate it. I hate it when I go to a workshop.
And what happens in those workshops? That somebody is talking and talking and talking, but never show us how to do the things that he's talking about. So this ends here today. Today, I'm going to show you how to deliver and how to build a robotics workshop where you can show to the people that attend the workshop how to do the things. For this, we are going to base the workshop on ROS. So we are going to use to make a practical workshop. What you will learn in this workshop is how you have to structure your workshop, your notebooks, your information that you are going to deliver to the attendants, how you can incorporate into your program, uh, into your notebooks, with the proper exercises that engage the attendants, and how you can deliver this workshop when you are at the venue. So stay with me until the end, where I will show you all the steps that you need to do in order to get these successful uh, workshops. And if you stay with me until the end, you will you will know a way about how to receive the bonuses that include those slides that you can see right now, and also an extra PDF document containing more details about the whole process. And then if you want to become to have a workshop that is ready in a record time with a lot of practice for the attendants and that doesn't require any installation, that's a place. This is the place where you are going to learn to do all those things. So by not requiring installation, I mean that the people who is going to practice in your workshop will have to do no installation at all of any software in the computers or else that you require. Just let me show you a few workshops that already use this method. That's one of the workshops that was done last year in November at the University of Luxembourg by Miguel Olivares. And based on his experience, what he reports is that it was an amazing experience, that people learned a lot and very fast. Another workshop is the one that is going to be done in April this year in Mexico by Luis Lupian. And this workshop is going to use the method explained here, actually the tools that we are going to show here. And another workshop that you can attend in case that you have the chance, it's also in April, but now it's not in Mexico, it's in Portugal, and it will be delivered by me and by Ralph from Bosch, where we are going to talk about ROS and how to learn ROS in different ways. And also we are going to teach about ROS too. So you have the chance. I will really suggest you that you attend this workshop, and it's going to be 100% practical. And then who is talking to you now? So that's me. It's Ricardo Tellez, and I am the CEO of The Construct. The Construct is a company that I run, and there what we do is that we build tools that make people to learn and program robots in an easy way. We basically use web-based tools. But let's switch to the subject of this webinar, that it's about how to build the robotics workshop and in a practical way. So this consists of 7 steps, that these are the ones that we are going to see right now. And they are very, very similar to the ones that we taught you last week about how to build a robotics MOOC, a massive open online course. They are very similar. So you will see. The first step is step number 0, is preparation. So it's actually not the first step, it's the step 0. And what does it mean? It means that we have to decide the environment that we are going to use in order to make this workshop practical. What is the environment composed of? It's composed of ROS, of course. We base this in ROS because ROS provides the tools that we need to do for practicing with robots, with programming robots. Then we are going to use Jupyter notebooks. The Jupyter notebooks allow us to include into some screen, web-based screens. It allows us to include the information that we want to teach, but at the same time, it allows us to include code, to include images, to include videos. So it allows us to include a lot of tools that allow the teaching experience to be very rich and engaging for the attendants. We'll see how it works in a few minutes. And then we are going to use Gazebo simulations. With the Gazebo simulations, we can simulate the robot. Then it means that the attendants will be able to practice with the robots that are in the simulations. Okay, so how do we provide this environment? We have basically, you have two options. Either you use local installations in the computers of the attendants, virtual machines, you provide that, or Docker installations, or you use an online system that already works on a website, like is the ROS Development Studio. And for these workshops, definitely do not use the local installation in the computers of the attendants. It's not going to work. It's going to be a complete mess, and people will waste a lot of time with installation problems. Please discard this. And why shouldn't you discard it? Because if you have the ROS Development Studio, that is an online resource for free that you can use. So please go to that, and that's what we are going to teach from now on the next steps. And for that, let's start with practicing, because in this webinar, you have to practice at the same time as I am explaining to you. And the first thing that we are going to do is to go and create a free account at the RDS. So in case that you don't have one, go to this address that is written here, rds.deconstructing.com, and then create an free account that you can use for the next exercises that we are going to do here. You should have received an email indicating that you had to create the free account prior to coming to the webinar. So I hope that everybody has done it. If not the case, then I will wait for 1 minute. In the meantime, I'm going to open the RDS myself. So I'm going to change the screen, and I'm going to show you my screen, my web browser, so I can show you here how I go to the rds.deconstructsim.com. Okay, so it happens to me, it appears this screen because I am already logged in, but in your case should be the page that describes the RDS, how to create the account, the free account. Just create it, then log in, and then you should get into a screen similar to that, but maybe you will not have those projects here. Those are the projects that I have created for other stuff that I have to do. And we are going to create one new project here altogether, so don't worry. Okay, so let's continue with the presentation. So I hope that all of you have your RDS account done and that you have opened, have logged in. Okay, so let's wait until we create a new project. So let's continue with the presentation. And we come back here. And for that, let me just, so we are here in this situation, we have already a free account on RDS. Great. Let's go for the next one. Next step. Next step is step number 1, that is to decide the subject of the workshop. Of course, you have to decide what you are going to teach. And also, you have to decide which programming language you are going to use. So in our case, for this tutorial here, for this webinar, we are going to create a workshop about robot navigation. And also, we are going to use Python as the language for programming in this workshop. I highly recommend to use Python for your workshop because it will eliminate a lot of problems. Otherwise, people can get confused with the C++ problems, and you will lose a lot of time trying to solve those. And the time in the workshop is limited. So by using Python, adopting Python, you can avoid all those wastes of time. Of course, everything that you do with ROS in Python, everything can be done in C++. But now the goal is not to learn C++, but to learn how to do things with ROS and how to learn about robotics by using ROS, actually. So highly recommended, Python. Then next thing, decide the units of the workshop. Of course, we have to decide the units of the workshop because it's the material that we are going to teach. So in our case, we have divided into 6 units. 6 units based on different subjects related to robot navigation, navigating with odometry, the sensors that requires for navigation, start with a SLAM and map building, localization, path planning, obstacle avoidance. And of course, we have included also a unit that is a project. That is something that we leave to the attendants to the workshop to do by themselves on the last couple of hours. So they can apply what they have learned into something from the beginning. That includes all the units knowledge. Okay, so now for that, let's create our first unit. How would you prepare your first unit for your workshop? That is what we are going to do right now in the RDS. So the thing is that we are going to create a project in the RDS. So let me show you how to do that. And let me change the camera so you can see how I do that. Then if you are here in this screen, something similar, let me know if you are not. And then you just press this button, create a new project. Let's press it. Then this appears, and then let's call it, like it said on the slide, that it's unit 1. Unit 1, odometry based navigation. It's a private project, and then the description. So this is the first unit of the workshop. Great. Once we have that, then let's create. And here we have unit 1, odometry-based navigation. Great, we got it. Next step. So we have the project. What do we have to do now? Okay, let's go to the slides again and see what is the next step. So next step is step number 3, that is to decide which robots we are going to use for the units. And the robots are the ones that we are going to use in the during the workshop in order to teach and to make the students practice, actually. So we are going to decide to use robots. We have to decide robots that are related to the subject of that we are teaching at that workshop. And also, I recommend you that you use different robots for the different units. By doing this, you will allow the attendants to practice the same concepts from different points of view. And that makes them to enrich the experience. They feel like more engaged because they are using different robots. That's something that everybody likes it. And also will allow them to understand better the concepts. So here is a list of different robots that I have selected for the different units. And in this case, we are preparing this for Turtlebot 3. So we'll work on this for the unit 1, okay, on the Turtlebot 3. So how do you get those simulations? Well, you can get them. You don't have to build it unless you want. Of course, if you are teaching about something specific to what your robot, you can, of course, create your simulation. But you don't have to. because it's plenty of repository with simulations of robots. In case that you don't have any or you cannot find it, here it is our public simulation repository that works with ROS Indigo and Gazebo 7. And here you can find a lot of different robots. Although the robots that we use in our online courses based on this platform that you can see on the image, or in our projects that we have, we put them all here in the project, in this open repo. So that's one example where you can get the simulations. For our example that we are building together, let's use the Turntable 3 simulation. And from this simulation, we are going to get it from the official repo of the builders of this robot. That is the company that is called Robotis. Robotis is the company that builds the Turntable 3. And we are going to use their repos, the 3 repos. We need 3 repos, different repos, for getting the whole information of the simulation of the robot. Okay, so let's do it together on the RDS. Okay, so do it with me. Let me change again and show you the screen. So if you remember, we left the RDS here with the creation of the first unit, and now what we have to do is to open this project unit. Okay, so let's press here. Everybody shows this small dialog with a description, and then we run. And then after certain times, it shows the, so I don't want to restore because I want to start from 0. So we have the ROS Development Studio main window for working with the development of programs for ROS. And then what we have to do is to put here the simulation of the Turntable 3 on this unit, because this is the project for this unit. You can see here the project that you're working in. Okay, how do we do that? First, let's open a shell. So click here on Tools and then Shell. We have our shell. I put it here in the middle. And then if you do an ls, you will see that we have here 4 different directories and 3 workspaces: the Catkin workspace, the notebook workspace, and the simulation workspace. It's in that last workspace where we have to put the simulation. So let's go to this simulation workspace and then source, of course. And here is where we are going to do the gits, the clones for all the packages that are required for the Turntable simulation. Let me just copy. If you don't have those instructions, you can get them from the original from the video. Sorry, in our webinar beneath you have the addresses for the git clone. So let me show you here. Actually, is here it's Turntable 3 robot simulation. If you click on this link, it will bring us here. And here we have the, let me see, where was it? It's here, it's on top. Here it is, git clone. So we have to clone, this is the first one. And let's change to the other one here. Paste, and 1. Then we have to clone 2 other more. And the 2 other more are here in the requirements that says install dependent packages. So we have to go here to PC software, install dependent packages, and those are the other 2 gits that we have to clone. So uncopy this, copying it, and doing it here in the same way. So it's cloning the other one, and then the final one that is here. Copy and paste. Great, I have cloned from the official robotics repo, I have cloned all the packages related to the Turntable 3 simulation. Remember that this is the robot that we are going to use in our first unit. So in case if you have a different robot for your first unit, you can clone other repos. This repo, the final one, it contains a lot of data. That is why it's taking so much. And then we have it. So we have the simulation here. Let's now compile the simulation before we launch it. And for that, as you know, from ROS, you have to go to the workspace and then do a cat-key make. Let's do a cat-key make, and here it goes. It's going to compile. In the meantime, let me show you that I'm going to put it here. So before we launch this simulation, we had to do a small modification on the packages. It's just on the launch file. It's very simple. I'm going to show you very, very quickly. So let's go to the packages of this using the code editor. That is easier for editing code. And this is another tool that you press here, tools, and then code editor. Great. As you can see here beneath, everything has been compiled properly. Now we come here to the code editor and we make it bigger and go to the source. Sorry, this is the cat-key workspace. It's not the one. We need the simulation workspace. Here, simulation. And then under Turtlebot 3 simulations, you go to Turtlebot 3 Gazebo, launch. And the one that we are going to launch is the Turtlebot 3 simulation. And here it says, hey, please provide a name of the model of the robot that you want to launch from the Turtlebot 3, because here in Turtlebot you have two possible options, the burger or the waffle. So you can launch either one or the other, and you have to select that in launch file. And for that, you have to provide here in the default value, the value that you want to launch. And it could be burger or waffle. Let's say burger. And save. Save is here. So now we have just modified the launch file that we want to launch. It's called the Turtlebot 3 simulation. And then it just modify the file to use the burger, to launch the burger Turtlebot 3 version. Okay, so now we have it compiled. We have modified this to launch the Turtlebot 3 burger version. So how do we launch it? Easy. Go here to simulations, and here you have a list of available simulations, Turtlebot 3, Turtle 3D, Sphero, Shadow Robot, many simulations already made that you can just press and launch. But now we are going to launch our own simulation, the one that we have installed in the simulation workspace. For that, we come here from simulation workspace, select launch file. Select launch file, and here, this is the one that provides by default, but those packages of Turtlebot have a lot of different launch files. This is not the one that we want to launch. The one that we want to launch is the one that we modified, that is the Turtlebot 3 simulation. And then we launch. Press launch. This new window appears. Let me put it here a little bit on this side. On this side. And this one, let me just put it. Okay, here it is. Waiting. So we are watching here the logs. We can see it in big screen, but okay, looks like has been a problem in the launch file. Let me see, maybe I mistaken the oh yes, that's right. Sorry, it's a mistake of mine. So I changed the simulation. It's not the simulation, but the Turtlebot 3 wall, the one that we have to modify, of course. So sorry from my side, it's a mistake. So we have to launch this one, the Turtlebot 3 wall. And this one is inside Turtlebot 3 Gazebo. Launch here, open it, and then modify this for burger. Okay, here, let's modify this. Burger. Okay, so it looks like taking the focus. Okay, let me, yes, right here. Okay, so I'm going to close the simulation and I'm going to take this here, burger. Okay, there it is, save. And then I save, file save, and then I'm going to launch now this launch file. That is the Turtlebot 3 wall. Let's launch it. This is the one that I have modified. So now it should appear here. So the problem was that I selected the other one that is a pre-launch file. So that this requires something else to have been launched. To all this code that is here beneath, that this doesn't include. And here it is. So here we have the simulation. And okay. Let me put it bigger. Let me put it bigger. Yeah, and here, let me hide the log of the simulation. And here we have the robot, the Turtlebot 3 burger. Okay, we got it. There it is. So now we have the whole simulation running in our unit. So we can start building exercises for it. So let's continue with the presentation and with the slides, and it will show us which ones are the next steps. Great, next step, step 4, create a notebook. The notebook is the place where we are going to put the instructions that the attendants will learn about our explanation. So it's also our guide when we are teaching, when we are doing the explanation for the workshop. We can use the notebook for ourselves as a guide at the same time that we show this to the students, to the attendants. And the Jupyter notebook is the one that we are using because it's web-based. Also, it is integrated into the ROS Development Studio, and we can include text explanation, videos, pictures, Python code, and we can even interact from within the notebook with the robot. So directly from the notebook, we can make the robot move, read the topics, or whatever we want to do with the robot using commands, using Python code or using shell commands. So let's see how to create a notebook. And for that, you can use the Python notebook that is already integrated into the ROS Development Studio. And now we are not going to create a notebook from zero, but instead we are going to use one that I have prepared. So you can go to this video, to the video of the webinar, and then beneath there is a link that contains a notebook example that I have already prepared. So we don't have to start creating from zero. So let's get that notebook, that file, upload it to the RDS, and then open it with a Jupyter notebook so we can start working from scratch. Okay, so let's see that, how to do this. In order to do this, let's change again to the RDS window. Okay, here it is. So if you go to the webinar, this is a webinar that we are looking at. And here we have example, notebook example for download. So press here, and this will open. This will open here for downloading, so you can download. Once you have downloaded, it's here on my browser. Just go to the RDS, and here inside the code editor, open the notebook workspace. Once you open the notebook workspace, here you can press the right button and say upload file, and then drag and drop this file here. Great. So it has been, and close, it has been uploaded here. Great. So the only thing that we have to do now is to unzip it. In order to unzip, let's go to the shell and go to the notebook workspace. Now, let's go to the notebook workspace. And here you can see that we have the zip file. And for that, it's unzip odometry. Great. Now it's done. And then we can remove this odometry zip file because we don't need it anymore. And here, if we come here, we can refresh, we scan, and then we have our PNB file that is the unit one, is the one that I have prepared, okay? So you should prepare this for yourself. And how do you open or how do you prepare this file? Very easy. Just go to the tools and open the Jupyter notebook. It's already here. This Jupyter notebook opens on this directory, the notebook workspace that we have here. So you can see that it contains the same files. Okay, yes. So in case that you would like to have and create your own notebook, just press the default. And an empty one, it's open, it's just a shell that shows you how to do it. So this is one case. And in this case, we are going to open the one that we have uploaded. Okay, that is already made. So let's open this one, the unit one. And here we have. Great. So this is the notebook that contains many things: comment, code, exercises, descriptions, and figures. And you can have a look at it and check it. We have also included a YouTube video. So in order to activate the YouTube video, you have to come here, select this cell, and then press Shift Enter, and then the video appears here. And of course, it can be played, and it's just a video that describes the notion of navigation. So the students will understand what I mean. And this is my example, but you can include whatever you want. You see, we have the descriptions that is explaining how to do it, the videos, the images, instructions, how to do it, more descriptions, also exercises. So it says, hey, launch this one and start moving, teleoperating the robot. So let's do it. So I'm going to copy this and launch it in the web shell. It's here, a web shell. So if I launch this, I should be able, yes, okay. So I'm not sure because this is the Turtlebot 3 and yes, okay, so it's compatible, yeah. So I have launched this command that is included into the notebook here. So I have this command that says, hey, make the Turtlebot move around using the keys. So copy this on a web shell. So that's what I have done here. I have copy and paste. And then this allows me to move the robot while I'm pressing the keys. So you can see that I am moving the robot around, making it turn forward, backwards, etc. And of course, you can do these things also including this into the own notebook. So for example, there is this command that echoes the odometry for one time. And if you press and activate this cell, you activate this cell and then press play, it will connect to the simulation, get the odometry information and echo it here. As you can see, so the notebook is interacting with the simulation. You can do more complicated things, okay? I will leave that to you in order to explore and find other ways of communicating. Of course, you can create whole programs that read the topics and do things with the topics, etc. Okay, so that's the way of building a notebook for the workshop that contains many, many things. Of course, you can run here even the RBs. If you copy this command and then execute here on the cell, oh, this is running. Let me open a new shell. You can open as many shells as you want. So I'm going to open the RBase here. Here, yeah. And then when it's launched, all the graphical tools of ROS need to be open in a new window, that is the graphical tools. So once you have launched it and it's successfully launched, go to the graphical tools, and here it will appear the RBase, and there it is, RBase, yes. And of course, you can configure as you want. We can add a robot, the TF, for example. I don't know. The frame is map, is not map, so we should select base footprint, for example. And okay, so these are the frames for the TF for that robot. I don't know, you have to check it exactly what those frames mean, etc. You can move it. This is the base footprint. And as you know, how it works for RBase. Great. So this is how to configure about the notebook. So let's go for the next step. And the next step is, let's see here. The next step is to provide example code. Of course, you have created the simulation. You have created the notebook that teaches how to do something, the subject that you want to do into the workshop. But you should also provide some code that the attendants can use as a template. Why? Because the time is limited, so they cannot create whole programs for in a couple of hours, or I don't know how many hours it will last your workshop, but just in a few hours they cannot create the most complex programs for your subjects of ROS, of robotics. Then it's a good idea if you can include some code that the users can the attendants can use as a modifier, as a template, or something that helps them. So let's see how you can include, by using the RDS, into your organization for your workshop, how you can include some code. So, and for that, I have also prepared some code for you. So let's go to the video again. And in the notes, you will see that there is some code that we are going to use it at the RDS. So let's get it, upload it to the RDS, and then execute it. Let's extract and execute it. It's very simple. You will see. I'm going to switch again to the application of the RDS, ROS Development Studio. Now I'm going to the webinar page, and here there is an example of package of ROS codes for the course. And if you press here, a new window with saving will appear. So I have it here saved, and then I return to the RDS and I do the same procedure. So for the RBs, I don't need it anymore, so I'm going to close it, and even the terminal. For the Jupyter, I don't need it, so I'm going to close it. And here on the IDE, I'm going to now change the workspace. So it's very important that you keep the things in the proper workspaces. So for the notebook workspace, we put the notebook files. For the simulation workspace, we put the simulation files related. And now for the code that the attendants have to create, or that they have to check, we have the Catkin workspace. And here's where all the code that is going to be created or executed, apart from the simulation or the notebooks. So let's come here to the source, and let's press right click and then upload. Where was it? Here. And then I'm going to drag and drop this, and my code is there. So I'm going to close it and then go back again to the shell, and let's uncompress it. For that, I'm going to enter into the Catkin workspace source, and then do the command to unzip that. It's a tar. Sorry. Those are the commands: XVFZP, and then the name of the file, TZ3. There it is. It has been extracted. Now I can remove it, the T3, remove it. And here, if I refresh, I have it. So it has created another Catkin workspace, another source. Okay, so this is because I have mixed it. When I compress it, I included those directories. Okay, but it's not a problem at all for the Catkin workspace, because here we have the proper code, T3 basics, that contains the CMake list and also the source. This is the program that I'm providing as an example. Okay, that's what is supposed that you should provide also. And let me open it. So if I open, and we can, for example, make it bigger, like put in here settings. Here, let me put it a lot bigger, so you can see. Basically, this is an example that shows how to create a node, subscribe to the odometry topic, and publish on the command bell. And if we execute it, then we'll see that the robot just prints the odometry sometimes, and then it makes the robot move here. It's very simple. So let's execute it. Very simple run. And for that is ROS run, because I don't have a launch. And then it's T3 course, and then the name of the Python. It's T3 courses. It's T3. Sorry, it's T3 basics. T3 basics. T3 basics, and then basics.py. Okay. So there it is. Then it's moving the robot here, as you can see, automatically is making a circle, a small circle, and basically that's it. So this is an example of how you can include a specific code that you can provide to the attendants. And everything is organized, is stored into 3 different workspaces: the Catkin workspace, the Noble workspace, and the simulation. Everything separated and well organized. So when you have to create your own workshop, you can structure like this. Okay, let's go to the next step. Which one will be? The next step is step number 6. That it means continue with the next unit. Of course, we have finished the first unit, and now we should continue with the second unit, third unit. It depends on how long is your workshop, how many units you want to put. So repeat the whole circle and use a different project. Yes, I really recommend that you use a different project. So you create a new project again, and you put everything on every project separated from every unit. Okay, great. So now it's time to share this with the attendants. So when the attendants come, you can share those units with them, and then they will receive these units directly inside the RDS without having to install or download or anything, just using their email, the email that they have used to enroll the RDS. So for that, you need to get the attendant username and then share it inside the RDS. Let me show you how to do it, okay? I'm going to show you here. It's very simple. So we are going to go to the projects page and then type here the names of the user. So if you have been following here, please write your username into the chat of the webinar. So I will share my unit, my whole unit, with all the emails that appear there on the chat. Okay, so let's do it. So I'm going to change again to the RDS, ROS Development Studio here. And first, before one thing is that we have to save everything. So we have included many things inside the Catkin workspace, notebook, simulation, etc. So now we have to save this project, because otherwise it won't be saved on the zone of the RDS. For that, press this icon, the save button. With this name is the name that we provide at the beginning, save. Yes, of course, I want to overwrite, and then it's saving my project. So now this project was empty, is being saved with all the data that I have added in the previous steps. And we are about to finish. So if you have any user for RDS, please put it in the chat of the webinar, and I'm going to share with all of the emails that are there. So it's taking some time, strange. Okay, saved, that was big. Okay, close, and then let me show you how to do it. Let me go to the chat and see if somebody has put it, the email. So no one wants to receive my package of the RDS. So inside the RDS, no. 5 seconds. 3, 2, 1. Okay, so I'm going to show you how to do this, even if there is no example. And the idea is that once you have everything saved, you go to your projects page that is here in the icon of the wall. And here we are again with the list of projects. Okay, here is my project. So I can put a share here, press this button, share, and this pop-up will appear. And here you can just write your usernames. And then it will be shared with the people, owner of those usernames. And for example, I don't remember if this is a user that has been created. You press enter, and you can put a whole list of the attendants here, one after another, and you will share at the same time. You don't have to go one by one, of course. Let me see if somebody has written. Nobody written. Okay, not interested. So just like this, write the email, username here in RDS, all the list, and then press share files. If this user exists, then it will show, hey, has been correctly, successfully shared. Otherwise, it will say, hey, there is a problem. Yeah, okay, doesn't exist. Yes, I imagine. Okay, but don't worry, that's not a problem. So that's it, how to share to the attendants at the moment of the workshop. That's it. So they log in, and then you share the project with them. That's how it works for creating a workshop with using this tool, this online tool. Okay, so let's see if still there is another step, and we are about to finish the webinar. So yes, the thing is that to do this, to prepare the notebooks, to prepare the code, the simulation, that's a lot of work. I've shown you how you can do it here practically in real time, how you can do it. But in case that you don't want to do it, because it's a lot of work, we propose you that you can use the Robotic Night Academy. That is an academy that already contains the courses for different subjects, and that it's already online. You can use it for your webinars, even for your university courses, by using the courses that we have already prepared. Those are courses that use the simulation, the notebook with instructions, and the code and exercises. We have courses for teaching ROS for beginners, and more complicated courses of ROS, even for artificial intelligence, autonomous robots, or even for specific programming of robots that exist. So how to program the Tiago robot, you have a course specifically for that, how to take the most of it, how to program this robotic robot Summit XL or the Tartarbot 3. So many things that can be done with the Tartarbot 3, how to take the most of that robot. We have a specific courses there. And we have a special discount, a % discount, if you use this live coupon that is valid until the end of the week, or the end of this week, just in case that you are interested. And that's it, basically. So I have finished the presentation. Now, if you want to get the bonus, send me an email to that address with the subject, I want to build my ROS workshop. That's the subject. And then you will receive the bonus. Remember, the bonus is the slides that you can see, and also a PDF file with extra details about how to do it. So Now it's time for your questions. So if you have a question, just post it on the chat, direct chat, and I'll be happy to answer. We have some minutes until we finish. So let me see. There is a question here about Daniel Sander. Will it be possible to start watching this in 2 hours and watch the whole 60-minute video? Then Daniel, yes, you can. Come and see the whole thing. Yeah, exactly. That's correct. That has been answered by Luis also. By the way, Luis is the one who is going to give the workshop on ROS at the Talent Land in Mexico in April by using this method, basically. Actually, he's using the academy for that. That the academy, the Robotic Night Academy, everything is built. So Luis has to go there and just explain. So he has to do the real teacher thing, that is to explain and support the attendants in the questions that they have or the problems that they have. Any question? Any question? So here we are waiting for some questions from you. I think that my presentation was so clear that no questions at all. Yes. Okay, so if you don't have any question, then I'll be happy to finish the session here. Just remind you before we finish that tomorrow we have the live show. The live show is where we solve the questions of people questions that people have about ROS in real life. So they have sent us the questions and we are providing the answer in real time there and showing you how to do specific things that people has found as a problem in their daily programming of ROS. And this is on Thursday afternoon, the same time. Also, remember to subscribe to our channel because we are publishing one new video every day. And those videos, as you can see, we present tutorials. We answer many questions in short videos of 10 minutes that you can apply directly to your ROS necessities. So subscribe to our channel and press the bell so you will be notified when we publish a new video. And that is all. Thank you, Petrus, for your comment on the chat. Thanks a lot. And if there is nothing more, I'll see you tomorrow at the live show. Thank you very much, guys. Keep pushing your ROS learning.